विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ।
Hello listeners, you're listening to Vigyan Ki Awaaz podcast program on STEM popularization, catalyzed and supported by the Ministry of Science and Technology, Government of India and Media for Community Foundation. Project devised and designed by Dr. R. Sridhar and assisted by Ashish Tiwari. Local coordination and production, Professor Subramanian. Content writing by Priyanshu and post-production by Professor Kaushik P. Kanchan of Garden City University, Bengaluru.
Garden City University, conquer we shall all adversity. Together we stand in unity. Together we strive for prosperity. GCU, emphasis on life. GCU, emphasis on life.
On today's episode, we are honored to welcome a distinguished physicist, Professor Srikanth Sastry. A leading researcher in statistical mechanics and condensed matter physics, Professor Sastry specializes in the computational study of complex physical systems. Professor Srikanth Sastry gave us an introduction into his research and how it is important for the society.
So my name is Srikanth Sastry. I'm a professor at the Jawaharlal Nehru Center for Advanced Scientific Research. I do research in theoretical physics, and the kind of problems I work on are concerning everyday things. All around us, you have liquids, you have solids. If you look around any room, study properties of these materials. And in particular, system that we have spent a lot of time studying are glasses. Glasses, again, are very ubiquitous. You see them everywhere. And but they are very unusual materials, because normal materials, when they're in the solid state, they are in what is called a crystalline state. Atoms in these normal solids like metals are organized in a very regular fashion. Whereas in glasses, if you were to take a microscope that is powerful enough and look at the microscopic level how the atoms are arranged, you will find that you cannot tell apart how atoms are arranged in a glass as compared to how they're arranged in a liquid, where they're completely disorganized. So a glass is a very typical example of what is called a disordered material, right, or a disordered system. And these are harder to understand than more regular materials like crystals. Something that, as a metaphor, glasses offer is this idea of multi-stability. So if you think about a crystalline arrangement of atoms, simplifying things a little bit, there's one arrangement that is the stable arrangement. Whereas if you have atoms in a glass, there are many possible different arrangements which are all locally stable. Okay, and this leads to a situation that in everyday language could be called complexity, but this is also a technical term. So a glass is an example of a complex material. Its properties depend on how you prepared it, and it is characterized by this property of multi-stability. So we do research both at a fundamental level as well as at a level which is close to applications of the properties of glasses, how they are made and how they come to have different properties depending on their history. Okay, something that we are very familiar in everyday life is not only us humans, but also things around you bear marks of the memory of what has happened to them. So if I look at this table in front of me, I'll see scratches and etchings that contain memory of what it was subjected to, right? If I bang the table too hard, or if I scratched it with a pen, these memories are present in most materials. But again, it's a very difficult problem to understand and study as a physics problem. So again, this is something that arises as a result of glassiness. And so we study this. We study how things break. And it turns out how glasses break, which is of course very important for your mobile phones, for your window glasses and skyscrapers that are made of glass, etc. How glasses break is a very important problem, and we study this, and we study how in general something that's in a solid state, but a disordered solid state, goes into a flowing state. So this transition from a rigid solid state to a flowing state is something that we study. And it turns out that there are examples of this in a very broad context. On the one hand, if you can think of molecules in a cell and how they might be either fluid or solid and what features control this. This is something that we are studying in the context of how chromosomes in a nucleus are organized. At a very different level, if you think of earthquakes and mudslides, these kind of natural catastrophic phenomena, these are also a result of something that is solid, the ground under your feet, becoming fluid, right? Under circumstances where too much stress is applied and so on. So the kind of work we do has very broad applications. All of these things are interesting. How memories form in materials, how materials remember the history of what they were subjected to. So these are the kind of things that we study. We study it theoretically by building simplified models. We also study these questions doing computer simulations. So we simulate, for example, a liquid that when cooled becomes a glass, or we study glasses that fluidize when we apply stress on them and break. So these are the kind of problems we study. As I already explained, this kind of properties of disordered solids, glasses, is a metaphor for a very wide range of complex systems, right? I've given you some idea. So at a fundamental level, it's relevant for a large number of things. One prominent example that you might familiar with from what you hear these days is machine learning. So when you have artificial intelligence, the science of artificial intelligence and machine learning are built on the basis of neural networks. And the physics of neural networks is something that's very closely associated with the physics of glasses. So this is one level. Glasses as materials, once again, have a very broad range of applications. The whole infrastructure of the information age is built on fiber optics, which are made up of glassy fibers. And incidentally, a relatively unsung hero of that story is somebody called Kapani, an Indian origin scientist who worked in the US. And we don't hear much about him for some reason, but he did the groundbreaking work of fiber optics. Okay, so there is a lot of different domains, such as immobilization of nuclear waste, making better optics of all kinds, etc., where glasses are used as materials. We don't directly work on these problems, though some of these things are of interest to us, and so we do things that may provide some answers that are needed for people to do practical applications with glasses. And so therefore, at that level, what we do is important for the country, because glass technology is certainly a big part of sustainable future technology for a variety of reasons. And we, therefore, part of the group of people who have the know-how about how these materials work. And as a scientific discipline, a lot of physics is well understood when there is some one stable state of matter, which we then try to characterize and capture the properties of. But things become very difficult when there is more than one stable state. Okay, this is in everyday terms. If I wake up in the morning and I ask, what do I do now? If there's only one answer, which is, get up and go to the office, then life is simple, right? But if there are 5 different answers, right? How to decide between these answers, how to organize your life becomes suddenly very complex. So glasses are the equivalent in physics of that kind of a situation. When there are multiple things possible, each of them are stable in some sense. But a real system decides between these different things. Okay? Let me stop there.
He also gave us a better understanding about how it is relevant to science and society.
So in terms of glass science and technology, India is neither very underdeveloped nor very advanced. So there are labs. In fact, last 2 weeks ago, I was in an international congress on glass, which brought mostly people from technology areas. I represented glass science and glass physics, but so there are a lot of companies, for example, which are involved in glass technology. There are organizations like CGCRI in Kolkata which do some research and development work. But given that there's a very large market, there is much more research and development that could be done. And there is interest, but I think, in fact, there's much more scope for developing research and development in these. In terms of glass physics, the basic science, again, we have a reasonable representation in India, including at JNC and the Indian Institute of Science and TIFR and so on. So there are a number of researchers who are fairly well known, but compared to more scientifically advanced countries, we are still a fairly small community, right? But, of course, one way to address this is to sort of have more and more and more. But I think it's important to sort of build capacity, but also quality. That's something that we need to do more of. There is a lot of work to do. But India has among countries in our sort of economic bracket, India does have a very reputable scientific enterprise. But on the other hand, if we want to be sort of a leading nation, we have a lot more to do.
He also gave us a better understanding about how it is relevant to science and society.
Okay, so in terms of how the kind of research that I do, let me not specifically talk about what I do. How is that going to help India in the long term? One thing is talking about the basic science part of it. There's a certain understanding of how sort of scientifically developed societies function and thrive. And the basic idea is when you have expertise and developments at the forefront of knowledge, they open out new dimensions for how in which you can develop technologies. And technological innovation is something that is important for modern societies to do well economically. And so the starting point is always that you have to be exploring the unknown. And that's what basic science does. And so just to give a very sort of trivial and well-known, not trivial, but a very well-known example, this year we are celebrating the 100 years of quantum mechanics, right? So, and 100 years ago when quantum mechanics was developed, people weren't thinking about high technology, they were thinking about, spectra that they were measuring that they couldn't understand, right? That's how quantum mechanics started. But then because you have quantum mechanics as a way of describing nature, other things became possible, and the most celebrated example is the transistor. We created the era of electronics which has transformed human society, right? And that is sort of what people point to as a roadmap for how basic science will contribute, right? There are things that we spend time trying to understand because they're not understood. But when we understand more, it becomes apparent what more things we can do with that knowledge, right? So this is sort of the justification for basic science in all advanced societies. But then there are more direct applications of this knowledge. And so one area that, as I mentioned, this meeting in Kolkata and other meetings that I've been to, one thing that people keep on talking about these days is the sustainability angle, right? How can we have materials that contribute to a sustainable future? And so glasses are actually a very good example of a material. It can be recycled very easily, it doesn't pollute, etc. And this is why people use it more and more. And this is certainly something that the country needs, right? And as I said, we have glass technology, like the bulk of glasses that are made are sheet glasses, right? And we do have industry that makes that. But that's not the premium level. So premium level will be like glasses for fine optics, glasses for re-entry vehicles, which then protect the re-entry modules from burning out. These sort of high-tech glass products are where the market is, or where the money is. Flexible glasses, and Gorilla Glass is something that, on your mobile phone. So for this, you need a fairly high level of know-how interfaced with sort of a technological drive. And this, I don't think in India we have enough of. You need to create that interface where people are actually working with high tech and also having a very advanced level of knowledge. So this is not a very specific answer, but there are things like I said, immobilization of nuclear waste. Every country that is using nuclear power has to deal with this, and people keep trying to sort of make better and better glasses that can help. Glasses are the only materials that can really do a decent job. So there's a lot of directions in which this kind of science and technology is very important. And the country needs to invest. But these are all sort of one type of answer, which is sort of looking at how it will benefit the economy and how it will benefit technology. But I think all developed societies need to have a high level of knowledge base, right? So I think you need to have universities where you'll have professors who actually understand and can transmit knowledge at a very high level, right? And this is always a need. And in the middle of the discussion about the economy and technology, we forget, regardless of how well the economy is doing, every year so many students enter universities who need to be taught whether physics will contribute to the economy or not. Everything that you do in engineering needs physics. And you need people to be understanding things at a level where we are not just consumers of knowledge, but we are creators of knowledge, right? And for this, there's a lot that goes in. You need to have a certain mindset about inquiring about things and how to go about then answering questions that you ask. Scientific research gives you a model that is very worth following. Even if somebody doesn't do research, if they understand the mindset of how you go about doing research in basic science, this will travel. Any profession you go into, you can use this. Okay, so at the level of education, higher education, I think we have a dire need for people who are trained and knowledgeable at a high level, who can transmit that knowledge to people who will then go do whatever they do, right? They may go into engineering, they may go into medicine, but they all need to know physics and chemistry at a level that conceptually they're sound. Yeah. So this is one thing that is a national need, and we don't talk enough about it. But there's also some people even sort of are worried. I'm one of them. That somehow we're always packaging things, even in education, and in the process of doing, you forget that however good your packaging is, if the foundation is not solid, it doesn't work. Right? So I think we have to really focus a lot more on the foundational education being solid. And so I think we all have to work towards those. And so the kind of work that we do is a template for how people should be learning to look at nature, look at technology. So there's always a place for it.
You were listening to Vigyan Ki Awaaz, a podcast on STEM popularization, catalyzed and supported by National Council for Science and Technology Communication, Government of India. Tune in for more such episodes to Vigyan Ki Awaaz on this platform and also through Spotify, YouTube and Apple Music platforms. Vigyan Ki Awaaz.
आइए हम सुने विज्ञान की अनकही कहानियाँ, आइए हम सुने विज्ञान